Welcome. Today I am going to discuss about of the name reactions related to the carbohydrates. So first name reactions is Wagner-Merwin rearrangements. Actually, the name reactions that no need to remember, no need to memorize. So just note that this is called that Wagner-Merwin rearrangements. Okay. Actually, that the concept is important. Remembering the name of the reactions, that is not important. Okay, so this is simply that concept. So you know that if we have that OH groups, that is alcohol groups, and if we have that HCl, then this lone pair will attack to this. HCl means that is H plus and Cl minus is there. In equilibrium also we have studied that whenever HCl is that is a strong acid that is actually in the water. So in the water that will protonate it to H plus and Cl minus. Let's say here water is also there. Okay, this may be aqueous medium or concentration medium. Then water is present. So at water medium, that is this HCl is, and that is going to give dissociate into H plus and Cl minus. And this lone pair will attack to this H plus. Then what we will get here, that is this carbon here, that is R and R, and this is CH2 and this O. So one lone pair is do the bond with the one lone pair electrons give to this H plus, so this is going to be H. Since one lone pair has went, so this is going to be positive charge, and here water is there. Okay, and now this is the water, so this will be released by taking this. Here electrons is there, so this water will take these electrons and leave, because oxygen and carbon electronegativity of oxygen is greater than carbon, so this oxygen will take all the electrons and it will leave. It means that here minus water will be released. So what we will get here, carbon and R, and this is R, and this is going to be CH2, since the lone electrons of this carbon is taken by this oxygen, because this bond has made one from carbons and one from the, let's say, oxygens. This is the oxygen electrons, and this is the carbon electrons. But whenever this water leaves, means that oxygen leaves, it takes the two electrons. So this carbon get the positive charge. Okay, so that the concept, so you know that things. So what will happen that now, since this is the 1 degree carbohydrates, and I said that whenever if that medium is nucleophiles or non-nucleophile, all the cases at 1 degree carbohydrates, the reactions will not happen. That will do the molecular rearrangement, means that a rapid rearrangement will occur. So here that migratory aptitude, we should know that. So we know that migratory aptitude, that is first hydrogens, then phenyls, then this alkyl groups, that is we can remember also as a hapur. So first hydrogen, then phenyl, then alkyl groups. So since here in these carbons all are alkyl groups are there, no phenyl, no hydrogen is there. So only chance is that only this alkyl group will shift. If here hydrogen or phenyl is there, then that migratory aptitude, that order is high, so hydrogen will shift. But here nothing is there, only R groups are there, so R will shift to this. So you can say this one as the methyl shift. Methyl shift occur. It means that what you get, this carbon, this is R, and this R. Since this is shifted to here, so here we will get that positive charge, and here what is that, CH2 and R. Okay. So because it will take that all the electrons of these two bonded electrons and it will shift to here. So this get the positive charge. Okay. Now what will happen? So this is the 1 degree. Now it changed to that 3 degree carbohydrates. So whenever you have the 3 degree carbohydrates, and now because here this is the nucleophilic mediums, and this is also that highest stabilized order of this carbohydrate, that is 3 degree carbohydrates. Now that nucleophilic will attack. So since here what we see in that Cl minus is also there and water is also there. Cl minus is also there in the reactions medium. Also water is also there in the reactions medium. But now that the nucleophilic order, if you see nucleophilic order, what that Cl minus, since here negative charge is there, and so if here that negative charge means that electrons are freely available, and on other case that water is there, here lone pair is available, but here that negative charge means that here that chlorine also need to do the charge neutralizations. So that nucleophilic order of this will be the greater than this. Okay, so that Cl minus will attack, not water will attack, because the nucleophilic order, that is Cl minus, is greater than water. Reason is that the chlorine has to do the charge neutralizations. Okay, and okay, so that's why that chlorine will attack to this positive charge, means that this will goes to here, because this here that electrons are freely available, so that will attack here. Because one more thing is that it has to do the charge neutralizations, whereas it is already in the neutral. Okay, so then that is going to give the product, that is C, here R, here R, here that Cl will come, and this is going to be the CH2 and R. So this is the final product for these questions. So this is the final product for these questions. Now moving to the next questions. So what is in that this type of reactions is called given the name reaction, that is Wagner-Mervin rearrangements. Let's say this is the first name reactions related to the carbohydrates. Okay, so if you not remember that name of this reactions, then also it's fine, we just know the concept. And this is very normal concept, that whenever acid is there and alcohol is there, then that type of rearrangement will occur, that we know these things. Okay, so moving to the next examples, this is the same case here, that is lone pair is present here. So this lone pair will attack to here, same things, whatever that is happened, the same things will occur. Let's say these things, and here that O is there, so one that lone pair is set to here, so this is going to be H, and now here we have that positive charge, and here we have that CH3, and here we have that CH3. So now the same things it will happen, that this water will release by taking that this electrons. So what here positive charge you will get, okay, here CH3, here CH3, and here we have that positive charge. Now what will happen, so this is the 2-degree carbohydrates. Okay, and this is the acidic medium is there, so 2-degree carbohydrates. And note that one thing, whenever there is a ring, okay, so just solve this example, after that I will discuss about that concepts. So this is the 2-degree carbohydrates, and here that H plus is there, so chances is that here also hydrogen is there. Okay, because in this carbon, okay, so one carbon can only have that 4 bonds, so four bonds are already there, so no hydrogen is present. Now what will happen, that migratory aptitude, we know that is here only that R groups are there, and for R group, so note that, okay, about of that migratory aptitude, first is hydrogen, then phenyl, then alkyl groups. Now in between the alkyl groups, what is there, 3-degree first will shift, then 2-degree, then the 1-degree will shift. Okay, first 3-degree, then 2-degree, then 1-degree. So here also the same things. So migratory aptitudes, then that is 3-degree, then 2-degree, then 1-degree. But here this is, so since this is already in the bond, so this will going to shift. Okay, that methyl shift will occur here. But this is the migratory aptitude order. Okay, but since here that is already in this ring, so here methyl shift will occur. So that is going to be, so here we have that CH3, and here we get that positive charge. Here also we have that CH3. Now since in this carbon, now that water is there in the mediums, so you know that water can act, either it can act as a base or it can act as nucleophile. Okay, so now whenever this type of questions will comes, then we will check the both the cases. If it will act as base, then what is the product? If it is act as nucleophile, then what is the product? And up to that you compare that which is more stable, and then that will form. So whenever that both chances are there, then for make that both the products. Okay, so now I'm making first here water. Now it is acting as a base, and now I'm taking that water that is acting as a nucleophile. So if it is act as a base, then what happened? Base means that will obstruct protons. So let's say that protons, either here is also there protons, because this car 1 2 3 4, or proton here also there. Okay, so it means that here the two products will forms, either here or here. Okay, so it can obstruct either here or here. So if this lone pair this act as a base, it means that this obstruct these protons, then this will take this and this we are going to shift here, or it is also chances that it will going to take this and this is going to shift here. Okay, so first I'm making that if it is acted this one, this is that 2. So if it is going to be 1, then what will happen? So in organic, always make that what are the chances you make, then check that which is more stable, and that will going to become the major product. So if it abstract to this, then that is going to, it abstract only proton, it will not take that electron. So this electron is shifted to here, so that is going to be take. Base means that base means that will abstract only that positive charge. Okay, that will not take that this electrons. So this electrons is goes to here. Then here we have that CH3, and here we have that CH3. And if it is abstract to this proton, then what will happen on that case? So that is going to be this, and here we have that CH3, and here we have that CH3. So this when it acts as a base. Now that case, whenever it acts as a nucleophile, then what will happen? If it is act as a nucleophile, then here simply that water will go. Okay, so now if it is nucleophile, then simply that water will attack here. It means that water will get the product. Here CH3 is there, here CH3 is there, then here we will get that water OH. Okay, because H plus, then that is going to do that, means that water will comes and it will be positive charge. It means leave like this, means OH will be there. Now check that which product should fall. Okay, now doing that all the chances, now we'll check that which, now we will use the concept of organics. So what the organic says that if uh, at the bridging positions, okay, if the double bond is there, then that is very unstable. That's why we know that the at the bridging positions, if double bond is there, then that is unstable. So this can't be Paul. Okay. Now this chances is there because CH3 CH3 and double bonds. And this case, look that OH is there. Now check that this and this, which is stable. So in this case, OH is there and this. So here this is more stable than this. So this will not fall, this will pass. So whenever in organics, make the all the chances, after that check the stability, which is the more chances to pop, and that will make the product, or look the options. Okay. Now moving to the next questions. Here also the same concept will apply. So yes, what I am going to tell that in previous class I told that if if the medium of the reactions if it is nucleophilic and non-nucleophilic. So what I said that nucleophilic, then if it is 1 degree so non-nucleophilic in non-nucleophilic case 1 degree or 2 degree, then what will do that rearrangement will occur. Okay, rearrangement occur, or 1 degree 2 degree or if 3 degree also, if that most stabilized form is the rearrangement occur to get most stabilized carbohydrates. But if it is in nucleophilic, then if it is 1 degree carbohydrates, then rearrangement will occur. Rearrangement means I can say that rapid rearrangements will occur. Rapid rearrangements occur to get 2 degree or 3 degree carbohydrates. But if it is, this is the A, but if it is 2 degree carbohydrates or 3 degree carbohydrates, then no rearrangement will occur. No rearrangement occur. And this is the case for the non-cyclic cases. But if it is a cyclic case, okay, remember that if it is a cyclic or ring is there, then what happened that whether it may be nucleophilic mediums, here let's say that nucleophilic, or let's say this is the non-nucleophilics, both the cases, whether it may be nucleophilic or non-nucleophilic, if cyclic is 4-member rings or 5-member rings, okay, sorry, if the if medium is nucleophilic or non-nucleophilic, both the cases, right, both nucleophilic and non-nucleophilic cases, if it is 4-member rings, 4-membered or 3-membered, means that what I want to say is that if medium that can be nucleophilic or non-nucleophilic, if the carbocation is in the 4-member rings, then always rearrangement will occur. Okay, well, that means that if it is a cyclic, then that if it is not, if the angle strain is there, okay, if angle strain in the sense that is less than 120 degrees, less than 120 degree angles, then always prefer to do rearrangements. Okay, so that angle strength, it always like to do that. Okay, whether it may be 3 degree, 2 degree, or 1 degree, always if there is angle strength, either it may be nucleophilic or non-nucleophilic at any reactions medium. If angle strength is there, then it always try to do rearrangement to get more stabilized carbohydrates. So this is the concepts about of that for cyclic and for the non-cyclic. Okay, for medium, that nucleophilic, non-nucleophilic, that is seen for the case of the non-cyclic cases. But for the cyclic cases, that nucleophilic or non-nucleophilic, both the cases, if angle strain is there, rearrangement definitely happen. Okay, that less than 120 degree, we can say that if angle strain is present, that is for member ring cases. For member ring cases, that always do the rearrangement to get the most stable carbohydrates, means to get a less angle strain, like we can say to get less angle strain, that rearrangement will happen. Okay, so this is the things that we should remember about of that carbohydrates. Okay, what I says that if the medium is, if it is non-cyclic, I should write it very clear, if it is non-cyclic, and here if it is cyclic or ring. So if it is a cyclic, then we will look that whether the medium is nucleophile or non-nucleophile. If 1 degree carbohydrate nucleophile, then rapid rearrangement will occur, and if it is 2 degree, 3 degree, no rearrangement will occur. And if it is non-nucleophilic, either it may 1 degree, 2 degree, 3 degree, rearrangement occur to get more stabilized carbohydrates. This is the case of the cyclic, sorry, non-cyclic cases. But if it is a cyclic, then medium, that may be nucleophilic or non-nucleophilic, both the cases. If angle strain is there, then always, like for member ring, always rearrangement will happen to decrease that angle strain. So actually to remove that angle stress. Okay, so this is the concept about of that carbohydrates. If I says anything wrong in the previous class, please correct it. Okay, this is the points. Now moving to these questions. Here, what is that? This is that four member rings is there, and this is that acid. It means that H plus is there. The same things. This lone pair will take this water, and that is going to be with this, and this is going to be remove that. That I have already explained. So this is going to be like this, and here we have that CH2 positive charge. Now what will happen? So here angle strain is there, so it will although this is 1 degree carbohydrates, now here also hydrogen is there, that it can do this one also. Chances is that hydride shift it will do, because up that migrate aptitude, we know that first hydrogen, then phenyl, then alkyl groups. So it may also chances that this can do that CH3, and here we have that carbohydrates. But this is the 3 degree carbohydrate, but again here that angle strain is there, so it will not do this one. What it will do that it will increase that ring expansions will occur to decrease the angle strain. It means that it will change to 5 member rings. How will do that? Just name it 1, 2, 3, 4, and 5. Okay, after that what we will do here, this one this is the positive charge, so leave this positive charge. What to do that? Now we want to make this bond and this bond, because we want to expand this ring. Okay, so if you want to make this bond, so I will make this one negative. Why? Because this positive and negative, that will make bond. Bond means positive and negative, so I will make this one negative because I want to make this bond. Okay, now leave this one, leave this positive charge. So if it is negative and this is the bond, so this has to be positive. That's because negative and positive, they will make the bond. Okay, this means positive and negative. So if I make this negatives, first we will use this positive, and we want to make this bond. So that's why I make this is positive, so this is negative. Okay, now leave this one. Now this looking this bond. Now I'm looking this bond. Now if it is negative, then this has to be positive. That's why the bond is there. This is the positive. So now make this bond 1 and 3 for 5. So, 1 and 3 will make bond, then 4 and 5 and 2. So here I will make this 1 3 4 5 and 2 is there, and what here is negative, so it will get the positive charge because negative and positive make bond. That's why here we will have that positive charge is there. Okay, now Br is there in the reactions, and water is there because Br has the negative charge and it has to do the charge neutralization. So here we have that Br. So this is the final product for these questions. Okay. Likewise, we can solve the questions related to that ring expansions and related to this carbohydrates. Now moving to the next questions. So wherever you see there is a four member rings, or wherever angle strain is there, first work is to remove the angle strain, because we seen that carbohydrates, that is a trigonal planar, and it has that 120-degree angles, means that to stabilize a carbohydrate in the trigonal planar, angle needed is 120-degree. So that want to do such type of reactions which is nearly to 120-degree. It may not be exactly 120-degree, but that should be near to 120-degree, so that angle strain will be removed. Okay, that's why now here what we see, that this is the four member rings. So four member ring means 90 degrees there, so it wants to release this angle strain. So what will do, that ring expansion will happen. So what is this? This is the group, this is there. Okay, so now what will do that, so what I says that this bond means positive and negative. So what I'll do here, this positive and negative, the here bond was that I want to make positive and negative. Where should I put positive and negative? So since this is the 3-degree carbocation, so here positive is more stable. So I will put positive, then I will put the negative here. Okay. Now this will give that H plus because that is acids. So this H plus is attacked by this. So here what will have, that hydrogen will be comes here. Okay. Now here we get the positive charge. So I want to increase this pore membrane because here angle strain is there. Then what I will do? So I want to make these bonds with this one. It means that this pore member ring I want to increase. So what I will do here, let me make that bonds here. Suppose what I will do, if I put here negatives and if I put here positives, if I put here positive and if I put here negatives, so that this positive and negative I will make the bond. Okay, because positive and negative I want to make the bond. Don't whenever you are making this, don't remember that this positive and the negative how will bond will make. So don't look that this is the positive charge, so leave this positive charge, this is comes from here. Okay, I'm not please for doing this first forgot about of it. So I'm looking consider for this bond. So for this bond, if it is negative, this has to be positive. Now I want to make the bond between this and this. Now you may get confused that this is the positive charge, this is positive charge, how this bond has formed. If it is positive, this has to be negative, or this is positive, this has to be negatives. But that concepts you will not just neglect for this time, because we want to remove this bond. So that's why I will, what I do, that this negative I will put the positive because I want to make the bond. I am doing the ring expansions. So I want to make the bond between these two. So here I will has to put negative, that's why I can make the bond here. Then if it is negative, this is the bond, so this has to be positive. Okay, for this just remove the just forget about of this positive charge for doing this bond positive and negative. Okay, so now what we'll do, that this negative and positive will make bond. So what we'll get here, So this positive and negative make bond here. This negative and positive make bond. Okay. So here that this has removed. So this we are going to get positive charge, and this positive negative make bond. So this is not there. Okay. So this is the product now. Now in the reaction medium, Cl minus is there and water is there. So which is more nucleophilic? Well, Cl. So Cl will attack here. That is going to be the answers. So here we will have that Cl. So this is the final product like this question. So we can solve this way the ring expenses concepts. Okay. So please don't confuse with that. This positive positive how this bond has formed. So don't look likewise. Okay. If positive, I want to make this bond. So this negative, then I has to put positives. While I am considering this bond, forgot about of this. Okay. Now make this bond and this positive charge remain. That will be that we can do it. Okay. Now it's the same things with this. So here AgNO3 is there. So AgNO3 means that Ag plus is there. And this Ag plus, what will do that? This chlorine is there. This is the Lewis acid. So this will share this lone pair to this Lewis acid, because Lewis acid is that electron deficient groups. After that, this will remove, that I have discussed in the previous class. So what we will get here, that CH2 and positive charge will be there. So there is also two chances it can happen here. What things we can do that? So I can do that ring expansions. Let's say this is the 1 and this is 2, this is 3 and this is 4. Okay, now I want to make this bond with this. So this is the positive, then I have to do this one negative so that I can make the bond. And now whenever I'm looking this positive and negative, now this is negative, then this has to be positive because I want to break this bond. So if it is negative, this has to be positive. Again, don't confuse this positive, this positive. Do remember that whenever I am considering this, I am not considering about of it. Okay, and now whenever I am considering about of this bond, I am not looking at this bond. So that things we have to be careful about of it, because we make because we may get confused about of that while I'm making this positive, this is positive, then how the bond has formed, because I already said that this bond means positive and negative, and this is positive, and how can it be this is the positive? So we may get confused about of it. Yes. Okay, so sorry. That's what I'm going to discussing, what I was discussing this one. So yes, so whenever we are taking this is positive, this positive, so we may get confused that this bond means positive and negative. So if it is positive, how can be this is a positive? So this confusion don't look likewise. Do that whenever I'm taking about of this bond, I'm not considering about of this. Okay, so if it is positive, this negative, uh, then this concept is okay. So whenever I'm looking this bond, don't look this one. Okay, this is negative, then this has to be positive charge. Okay, so while doing these types of ring expansions, please make sure about of it. So whenever I says that this is positive negative, this bond will forms. On the time I'm not caring about of it. Whenever I'm looking this bond, I'm not caring about of it. Okay, that things we should remember. If you do this, don't care about of it. If you do this, don't care about of this. Okay. So now I'm talking about of this, so I will not care about of it. So now I will make this bond. So 1, 3, and 4, 2. So this is going to 4 member rings. Let's say this is 1, then this is 3, this is 4 and 2. And whenever I'm talking about of this, then I will not care about of it. It means that this is 1 and 3, and 3 is getting negative charge, and this positive negative make bonds. And whenever I'm carrying this, I will not care about of it. It means that 3 and 2, this bond has break. It means that if it is negative, then this has to be the positive charge. So that's why here positive charge is come. Okay, so now that's see water is there in the medium, so water will comes here, the positive charge, so that will attack here and that water. But what you see that this is the 4 member rings, so 4 member ring again angle strain is there, so this will not form, means here positive charge is there, so here that is no chances of further ring expansion, so here water has to come. Okay, it means that here water will comes, but this is that 4 member ring angle strain is there, so this will never form. So here what happened that directly that water will comes here, sorry, this will attach to here, that is going to be CH2OH. So this is the product forms, this is not form. Okay, likewise we can do both the cases, and we'll check that which is more stable, that will make the final answers for the product. Okay, in organic always make that what are the possible options, do that, after that check the stability, which is more stability, which have the more stable, that product will form. Now moving to the next questions. In these questions also what is there, that here lone pair is there, in the H2SO4 means that is again acid, strong acid, H plus will be there, that is going to share here. So this is we are going to get this one. Okay, H. So here we have that positive charge because lone pair which make donate its electrons to H plus and this form. Now since this oxygen is more electronegativity than carbon, oxygen is more than carbon, so now carbon has the positive charge, so this is not stable, so this will attract electrons to itself. It means that what we'll get here, or this is going to be H, this bond is shifted to here, it means that here we will have the positive charge, and here we have that ring, this 4 member ring. So here what you see, that 4 member ring means angle strain is there, so what will happen that it will increase its angle. Okay, so what I have seen, this is the same like this way, CH2 positive charge. What is to do that, what we will do, 1 2 3 4 5 each do angle strain, so same manner we can do here, 1 2 3 4 and 5. So that concept we will use, whatever I say, that if it is positive and I want to make the bond with 3, so this has to be negative. So whenever I am talking about of this, I will not look about of it. So this bond is going to break, this bond is going to break, and if it is negative, then this has to be a positive charge. So here positive charge will be remain here. Okay, I make the bond here, I am going to break this bond here. So if it's negative, then this has to be positive charge. So don't confuse this positive positive how this bond has formed. Don't look that one. Whenever you are looking this, and that time look this. Now I am looking this, then don't consider about of it. This negative and positive. So if it's negative, this has to be positive. Okay. So likewise, now I will make the bonds now. So here 1 and 3 will make bonds. Here OH is there. So 1 and 3 make bonds. This one, 1, 3, 4. Okay, this is 1 and this is 3. This is 4. This is 5 and this is 2. And 2 will have the positive charge. Okay. Because what I say that here positive charge is there, so that's positive charge, I make it. Now what I will do, so if it is a positive charge, so remember that whenever you are forming the ring, so 5-member ring is more stable than 6-member ring. Reason is that ring constructions. So that 6-member rings actually that form the 5-member rings. 5-member ring is more stable than the 6-member rings. This is more stable. Reason is that there is a ring contractions that is very less for the 5-member rings compared to the 6-member ring. Okay, that I also explained that 5-member rings is actually exist in the envelope forms. Okay, and whenever sometimes 6-member ring is convert to the 5-member ring because 5-member ring is more stable than 6-member ring. Reason is the ring contractions. So now what we'll do that this 6-member rings. So let me give the names here. 1, 6, 7, 8, and 9. Okay, so now what will happen that this is the positive charge, so I can make here negative charge, and I want to make this bond between this and this. Okay, now if it is negative, I am looking about of this bond. If negative, then this has to be positive. Now what I want to make that this one I want to make bond and this one I want to break here. Okay, so what we will get here, this one, and this is going to be like this. This is from 6-member to 5-member ring. I'm making that one, and here we have that members. Let's say then here we have that OH. So this one, this is the one. So this is what with that will be the positive charge because negative. Then this is positive charge, and here this is the 2, and this is the 6. This is the 7. This is the 8, and this is the 9. Okay. So now at the 2, what have that the ring is there. This ring, okay, that is 1, 2, 5-member ring is there. Let me make positive charge here. Okay, so 1, 2, 3, 4, 5-member rings. Okay, in this way it is there. Now this is also 5-member ring. This is also 5-member rings. And what that this lone pair is there, so that will share here, and that is going to make this type of rings. Okay, and here we have that this is the final product for this questions. So you can make this type of ring expansions in case of the carbocation cases. Okay, now moving to the next questions. This is also very interesting questions here, and what we will do that here lone pair is there, so this will attack to here. So what will get that one. Okay, so this is going to release water is released. Let me release water. So here what we will have CH2 and positive charge is there. Okay, now what I will do that ring expansions I can do from 5-member to 6-member. So that depend on that where it is, sometimes 5 to 6, 6 to 5. Okay, but stable is 5-member rings. Here the reason is that here harmonizations will happen. Let's see. So if I make this one as 1, Okay, I want to, this is positive. I want to make the bond, means I will have to do here negative, because positive and negative will make bond. Okay, so I want to make this one and this. So let's 1, 2, 3, 4, 5, and 6. So 1, 3 I want to make bond, and if it is negative, this has to be a positive charge. Okay, so don't look that this positive positive. If negative, whenever I'm considering this, then I will consider this. Whenever I'm looking this, forgot, please forgot about of it. So this is get the positive charge. So where here I will make bond, here I want to break it. Okay, so how can I do that? This is like this, this is like this. So what I will do here, this is the 6-member ring is there, and this is also again going to be a 6-member ring, 1, 3, 4, 5, 6. So make that. Okay, and this is 1, and this is 3, this is 4, this is 5, and this is 6, and this is the 2. Okay, and 2 will have the positive charge, so make that positive charge here, and this is like this was there, so make that same things. And now what we see, that 6 and 5, this ring was there, 6 and 5, this ring was there, so make that things. Okay, 6 and 5, this is there, so I'm making that one here. Okay, here also 6, 5, that is there, like that. And here we have that positive charge. So how can I do that positive charge? So here water is there, so water is can act as base as well as nucleophile. But here what we see, that here we have that hydrogen also, here I have that hydrogens. So if I will abstract that it is used as a base and abstract it and it will share it, we get that aromatizations. Aromatizations will occur. And if you are getting aromatic, and that is become a past reactions will happen. It means that what is seen here. So if I take here electrons, then what we see, that it become a aromatization, means all the 3 members ring become a aromatic. It means that it will do a very fast reactions, because this is the more stable product will happen. More stable product. Okay, so that's what it is happened. And here what, this water is act as a base. Not that even if here nucleophile like Cl minus is there, then also that Cl minus will not come here, because that here aromatization is happening. Okay, and aromatization is a very stable product, so nucleophile will not attack. Here water will attack. Reason is that here more stable product we are getting. So in organic you will look that where we are getting more stable product, that will pause. Okay, that nucleophile will not attack, although that nucleophilic character of nucleophile is more than water, then also this water will act as a base. That's why whenever we will solve organic, we will solve that all the possible products. After that we will look at which is more stable, that product will be the answers. And same time we will look the options, and according to options we will solve the questions. That is the basic fundamental how to solve the questions from organic. Okay, now moving to the next name reactions that is related to aromatic system, that is that aromatization reactions. So what we see, that in adamantane, this adamantane is actually that product which is thermodynamically very stable products. Okay, so whenever in a compounds, if it is has the 10 carbon atoms, okay, if it has a 10 carbon atoms, then they always form a adamantane. Why? Because this is a thermodynamically stable product. Thermodynamically stable product. Okay, so whenever 10 carbon atoms or more than 10 carbon atoms are there in a molecules, then they will form an adamantane. Reason is they are thermodynamically stable. Okay, So if 10 atoms, then adamantane will form. If 11 atoms, then adamantane will form, and after that, uh, what that substitute will be for that next compounds. That we will see by looking these examples. See here that how many carbon atoms are there. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 carbon atom systems are there. So it will form an adamantane. Adamantane means this type of molecules. This is the adamantane. Okay. So look that 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the adamantane. So check here how many carbon atoms. Let's say 1, 2, 3. I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is called adamantane. So whenever in a molecules 10 atoms are there, then that will form adamantane. The reason is that this is thermodynamically stable product. Okay, now if we have that more than 10 atoms, let's say here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then what will happen that whenever 10 or more than 10 atoms are there, always adamantane system will forms. This will form like this. Okay, so 10 atoms has formed the adamantane. After that, remaining 2 atoms, they will form the substitute product. Substitute product at the bridgehead positions. It means that one will be here, another will be the here. That the bridging head positions it will form. Okay, at bridgehead positions they will form like this. Now here we see that 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, and 14. So here again more than 10, so adamantane will form. Okay, so 10 atoms and remaining are the 14, so that will form at the this bridgehead positions. Here CH3, here CH3, CH3, and here CH3. So all at the bridgehead positions that the substitute product will forms. Okay, so like that we can do that. If more than 10 atoms are there, then form the adamantane, and 10 atoms will be the adamantane, and remaining 4 will be the substitute product will forms at the bridging positions. Okay, so this is about of that name reactions that is related to the carbocations. What happened here is actually we just give to the we have to give the heat, then this will form. Reason is that they are very thermodynamically stable product. So by simply giving heat, they will form the adamantane. Okay, this is also the name reaction that is related to the carbocations. Here also intermediate carbocation will form. Okay. Hmm. Moving to the last reactions for today class, that is Dam-Jeneb rearrangement. This is also name reactions related to the carbocations. Here what will happen that let's say we have that CH3, CH2, and CH2, you have that OH is there, and let's say we have given that HNO2. Actually how this, sometimes this is given, or sometimes what will given that CH3, let's say CH2 and CH2, and OH is there. Now they will given that Na2 plus HCl will given. There also how will do that? This Na plus and Na minus, and this what will happen that H plus and Cl minus. This is going to form that HNO2 plus NaCl. So it may give this one directly, or it also give like this. Then also we can form that HNO2. Okay. So whenever you take either it will give like this or it may give like this. So you can solve these types of questions. So this HNO2, this is how, that is OH, and we will have that NO2. Okay, this we can write as OH NO2. How we form the HNO2? That I have explained that. That is from Na2 plus HCl, then we can form that HNO2 plus NaCl. Okay, so on this OH and HNO2, that is can written as this way also. Okay, now here we have that HCl. So we have in the reaction HCl also present because we have given HCl. So this HCl give H plus. So this H plus, this OH is there, and this will attack to this H plus. Then what will give that NO, and this is OH, and this is OH. This is going to positive charge, and it will leave that. Then what will have this NO plus is there, and this NO plus is attacked by this lone pair of electrons. So this is going to attack this one. What you get here is 3 CH2 CH2, and this is going to be the, okay, here OH will be not there here, sorry. Here we have that NH2. Please remember that here we have that NH2, not OH. Okay, so now what will happen? This lone pair will attack to this. Here NH2 is there. So this lone pair of NH2 will attack to this. Or we will do these reactions in the next class. Today up to this. Thank you.